Hello everyone, my name is Saad and welcome to my YouTube channel. Today I'm going to talk about summation notation and product notation. But before we jump into the video, I have to talk about something that has been noticed by many viewers recently, and that is the fact that I have not been able to upload a lot of videos recently. So I'm very sorry about that. Now let's get into the video. So, let's say you have a nice teacher. So this is you, and you have a nice teacher. So your nice teacher tells you to write down 2 plus 3. Well, you know 2 plus 3 equals 5, but he tells you to only write it down, not actually write 5. So you write down 2 plus 3. Then he tells you to write down 2 plus 3 plus 4 plus 5. So you write down 2 plus 3 plus 4 plus 5. Simple. It's pretty simple. But then your teacher asks you to write 2 plus 3 plus 4 plus 5 all the way to 100. Now you say, how is that possible? Like, it's going to take up an entire page. Like, that's basically impossible to write. That's basically a waste of time. So, but your teacher says that you have to write it still. So, without any options, you write it. Except, what you didn't know was that you could have written it in another way. And that way is this. You could have written 2 plus 3 plus 4 plus 5 all the way to 100 like this. This symbol n equals 2. On top of this symbol is 100 and then an n. What in the world does this mean? Basically, this is a function, okay? A function is basically like, let me give you an example of a function. Let's say this is a machine. You know, a machine that does functions to an input and an output. This is the input. This is the output. Let's say this is the function. Okay, function. Okay. So now, let's say you input, let's say, I don't know, apple. It might give you orange. If you input, let's say, a number like 25, it might give you 31. If you input another thing like a bus, it might give you a train. Like it just does, it takes the input, does some things to it, and then gives us the output. So basically that's it. So basically it could take a number as well. Let's say we have a function wait, let me actually erase this first. Erase this diagram of a function first. Okay. So this. Let's say you have a function. Okay, I'm going to draw the entire diagram again. Let's say you have a function, and the function does n plus 2. Okay? So it basically adds to any number. So, let's say you input 35. It will give you 35 plus 2, which is 37. Let's say you input 96. It'll give you 96 plus 2, which is 98. Let's say you input 102. It'll give you 102 plus 2, which is 104. So let's say you input, I don't know, a big number. Let's say a Google. Yes, this number is called a Google. It says 10 to the power 100, written like this, or also written like this, is just 1 with 100 zeros after it. So this function will give you a Google plus 2. That's it. It just does n plus 2. Like, n could be any value. These inputs are n. And n plus 2 is the output. So basically, a function could be anything. It could be 2n, n squared, 2n cubed, 3n squared plus 5. Anything. Basically anything. Any expression, any algebraic expression. Sometimes functions can have multiple variables, which means multiple inputs. That's, in fact, x plus y squared is also a function, even if it has two variables in it. So basically, what this does is basically it takes this function. Also, look, this could be also written as the same symbol, t this time, t equals 2, above is 100, and then t. Like, the variable does not matter. This should be the only variable inside, like after the symbol. Also, do you know what this symbol is called, by the way? It's called sigma. Sigma is in a Greek letter. So basically, Greek letter. It's a Greek letter. So basically, t, anything, any variable. I mean, you could have tn here, even though it only says t, but tn is like, n could be anything. This is also a function of itself. This is a number, but this is a function because it's has an extra n here. Okay? So basically, what this does, let me actually erase it again. What this does, basically, is it takes the function and makes the main variable, which is here, equal this to this number. So basically, what if n equals 2, this function, which is n, equals what? 2. If n equals 3, then this function, n, equals what? 3. n equals 4, this function equals 4. So basically, that's it. It does this all the way to n equals 100. What happens if n equals 100? The function equals 100. Okay? And what is 100? 100 is the number on top. So basically, this is it. Like, I'm gonna represent this algebraically. Okay, let's say this is x. X equals some number j of f of x. And then to some number m. This is basically equal to f of j plus f of j plus 1 plus f of j plus 2 all the way to plus f of m. So it's pretty simple. Like, this is pretty simple. So basically, let's try some problems. This one is pretty simple. Like, this is pretty simple. Also, if you have like a very large number, then, well, there is a shortcut way, but that's not what we're going to focus on this video. We're going to focus. Okay, so let's try some practice problems. What is the sum? Yes, that's how we pronounced it. What is the sum from n equals, let's say, 1 to 20? Well, 20 is a big number. Let's actually shrink that. Cover how to do big summations like that later. Let's do 5. 5 of, let's say, n pi over e. Ne, which is pretty, like, special. Wait, pi n. Let's say n squared. Okay, n squared e. Well, this is now, one thing that you guys may not realize is that, look, n pi over n squared e. Some algebra students might say that we can cancel these out to get pi over ne. That is correct. But some students, like some people, might actually argue that you should not be able to do that because, well, it's inside the summation symbol. See, that's sigma. It's inside the summation symbol. So how are we able to do that? But still it works. That's actually wrong. You can actually just, do the same algebraic formulas and stuff that you used to do. So this is still pi over ne. So it's still correct. Now let's evaluate that. That equals pi times 1 times e, pi over 1 times e, which is pi over e, plus pi over 2 times e, 2e, plus pi over 3e, plus pi over 4e, plus pi over 5e. This is pretty complex, you know. We have to do many addition steps because here is the fraction. So let's actually evaluate this. Okay, I'll write it again. So the next thing, this is like a fraction, so it will be tricky at first. It may seem tricky, but basically we have to get this to like a common, excuse me, to a common denominator. Basically, that's it. So basically, the way to do that is we'll do it step by step. What is pi over e plus pi over 2e? Now, you can say that you can just multiply this by 2 and get 2 pi over 2e. So, you can say that is equal to 2 pi plus pi, which is 3 pi over 2e plus 2e, which you don't need to care about because it's the denominator. So now, plus pi over 3e is what we encounter, plus pi over 40 plus pi over 5. Okay, so that's not 5, I mean pi, not 5. 5 is in the denominator of the fraction, so this is pi 5e. So now what we have to do is to multiply both sides by these by 3 and these by 2. So basically that's it. So basically this is 2 pi and 2 times 3e, and this is 3 times 3 pi over 3 times 2e, which equals 9 pi plus 2 pi, okay? So 11 pi over 6 pi, 6e, because 2 times 2 is 6 pi over 4e plus pi over 5e. Now we have to do that again, but now we have to multiply this by 4 times, and have to multiply this by 6. 4e6, that does not make sense. 6 times 4, 6 pi. Okay. Now, that is 44. 44 plus 6 is 50. So it's 50 pi. So 50 pi's, that's a pretty big number, over 24e. 4 times 6 is 24. So 24e. Now we get into the final step of this problem. The problem is almost done. So now we multiply this by 5. Multiply by 5. It's basically multiplying by 5 over 5. And then multiply this by, well, I don't know. So 5 times 24e is basically 5 times 24 times e. And those could be grouped together. So basically we have to multiply these by 24. So pi times 24. This times 24. And now we've come to the final step of the problem, and that is 50 pi times 5. 50 pi times 5 is 250. Pretty sure, 250. 250, and now there's a pi here, so 50 pi times 5 is 250 pi. Over 5 times 24e. So basically there's this trick. But I'm not going to show it. I'm just going to write the original answer, 120e plus pi times 24, 24 pi, not e, and 5e times 24, we already discussed, 120e. And now the final step of the problem, 274 pi over 120e. That is the answer. Many people will say that, hey, this can be simplified because both are even numbers. Yes, this can be simplified, but let's just not simplify it. So, the sum from n equals 1 to 5 of pi over ne equals 274 pi over 120e. Pretty good. Or else we have to write this entire thing down and evaluate it. Now, this does not help to actually evaluate it, okay? So if you evaluate this, you have to actually write it out. Like, you have to do the addition problems. If you don't do the addition problems, you're gonna get the wrong answer. Let's try one more example. Okay, one single example. Let's say n equals 1 to infinity of something very big. Okay, 1 over n squared. Many people know the solution to this problem, and it is absolutely magical. So basically, we're not going to learn how to evaluate an infinite sum. Like this is I'm going to write it out. It is 1 plus 1 over 4 plus 1 over 9 plus 1 over 16 plus 1 over 32 plus 1 over 64 all the way to infinity. Okay, it does not ever end. So I'm not gonna teach you how to evaluate this. Instead, I'm gonna get right into the answer, which is absolutely magical, by the way. It is pi squared over 6, which is absolutely just unimaginable, because why in the world is pi here? I mean, does this have to do anything with circles? And basically, if you're wondering what is pi, is a circle, diameter, let's say this d, the circumference, the perimeter, this is c. So basically, c over d in any sort of circle is pi. Okay, that's it. Pi is about, I'm gonna write pi up to a lot of digits here. 3.1415926535897, etc. It continues on forever. It's an irrational number. It's not irrational. I mean, it's not rational, not irrational. Now, I'm going to give you some two functions which are based on the idea of summation notation. First is the zeta function. So zeta of s. So basically, now this is the Riemann zeta function. Well, this is the zeta function, but the Riemann zeta function is a whole other beast. Like, it is absolutely magical. So the zeta function, well, the analytic continuation of the zeta function is the sum from n equals infinity, n equals 1 to infinity of 1 over n to the s. So that thing we just covered, like that thing, is just zeta of 2. So that sum that we covered is just zeta of 2, which is pi squared over 6. Okay. And another function, which is the Lambert function, normally represented by w or w naught. Normally represented by w or w naught. I'm going to use w. So w of n is basically, this is like the reverse, like inverse function. I know it's like some summation thing. I don't actually remember it. But look, I don't actually remember the Lambert function, like what it is. But I know it's the inverse of the function x e to the x. So the Lambert function, basically, if you take the Lambert, yes, that's what I mean, of x e to the x, like if you take any number, it's just going to result in x. Basically, this is the inverse function to that function x e to the x. It has a summation form. Maybe we'll cover in another video. It is very important. It shows that I'm in a lot of problems. So basically that's it for this video, and make sure to comment, like, and subscribe, and share this video to your friends and family, and bye bye.